Hi, my name is Samuel, introducing today our hybrid time of flight module. This is a depth sensor with over 20,000 pixels of resolution. We have two of those in our robot, on the front and on the side. These modules create a depth map by sending out infrared radiation or infrared light and measuring the time of flight it takes for the light to return to the sensor for each and every one of those pixels. Now let me show you how this looks in real life. So I'll connect this here. So why is this a hybrid time of flight sensor? It's because it has two illumination modes. What you see in front of you is the flat illumination with me standing in front of you. So here you have 20,000 pixels with a range of up to 2 meters. The color corresponds to the depth in this case. Then I'll switch to the other use case. Running at the same time, we have our spot illumination with only 600 individual pixels, but up to 8 meters of range. In a robot, this will be used for mapping and navigation, while the flat illumination will be used for closer obstacle avoidance and object detection. On our robot, we have two of those sensors, one in the front and one on the left side. Together, they cover about 180 degrees horizontal field of view. They're connected via USB to the brain of our robot, the navigation unit, which is an NVIDIA Jetson Orin. Here the depth data is processed and the SLAM algorithm, the mapping algorithm, is performed. This allows our robot to build a map of its environment and navigate in this environment, avoiding obstacles and finding its way around. For this, we use, in our case, the open source stack of Google Cartographer and ROS. If you want to include one of those sensors in your own robotics project, you need to first of all think about the compute platform. You need something quite powerful like a Raspberry Pi or a Jetson Orin like we used here. You go to the PMD website and download the SDK, load it onto your compute board, unzip, and follow the examples there. You have a wider range of SDK APIs like Python, C++, MATLAB, and ROS. If you would like to know more about navigating with this hybrid time of flight and how we did it on the IMR, employing SLAM and the navigation algorithm, check out our webinar. Thanks for watching and see you next time.